we're going to spend a little bit of time talking about FHIR in terms of a standard, and then we'll move into InterSystems and how InterSystems products support FHIR in different ways, including the FHIR server and some of our more advanced FHIR features. So I don't want to go into too much detail about this, but the history of FHIR here, but there are a few milestones that I wanted to point out and a couple of important things that I think to take note of here. So HL7 was founded in 1987, was accredited by ANSI in 1996, and has been developing the HL7 standards ever since. Traction was very slow, and it wasn't until version 2 in 1989, with the first real usable version in 1990, version 2.1, where the standards finally started to gain some traction. And in the late 90s, I think we started to finally see an uptake in utilization of HL7 version 2, and it became a critical mass as a viable health standard. So we started to see it in use across the healthcare landscape. In the 2000s, focus was really shifted on creating electronic health records and longitudinal records and consolidating patient information into enterprise-wide views of a patient's data. So, as a physician, I would want to see all of the other healthcare-related data for my patient from other entities. We saw a lot of focus on EMRs and the data being supported through those various vendors. In 2005, we saw a new version, HL7 version 3, but when it was created, it wasn't backwards compatible with version 2.0. And so that kind of stalled the development of it there. And, we continued to see usage around version 2. Version 3 is still available and is still in play, but version 2 is really predominant today. In 2011, HL7 began a work group to address the challenges of the V2, V3 standards. There had been a lot of feedback at this point, a lot of suggestions for improvements. A lot of the challenges were recognized, and so they effectively decided to create a completely new and modern standard for healthcare interoperability. And so in 2014, we saw the first draft standard for trial use for FHIR. We saw projects like the Argonaut project conceived to create practical implementation guides. So, in conjunction with the standards themselves, we're seeing guidance for how to use those standards effectively in combination with one another, in combination with different use cases. And that started to pick up as well. And this development continued until V4 in 2019, which I think is really considered the first normative version, meaning it's widespread and it's mature enough and can be really used for viable implementations. And so the important takeaway that I wanted to point out here is how this HL7 version 2 sort of stalled, and now we're moving on to a new a completely new version, which is now called FHIR. FHIR adoption, I think now, as I mentioned, it's with a widespread use and a viable standard, we're finally starting to see this pick up. So similar to the progression with version 2 utilization, FHIR started off slow, but I think now we're starting to see some key adoption milestones. We're seeing high adoption in different spaces in UK, Germany, the European health data space. We're starting to see standards unified across member states. Different compliant, FHIR compliant systems are starting to be implemented across the globe. And in the United States, we're starting to see legislation really driving adoption of this, which is one of the key reasons that vendors will support advanced FHIR functionality. And for interoperability, it's something where we really need the standards to be enforced so that we can have true interoperability between different systems and different vendors, especially. U.S. healthcare payers are extremely slow to adopt new technology, and so sometimes regulation is the only way to move the needle. And especially these CMS and HTI regulations have mandated both participation in fire from EMR systems as well as health insurance payers. And so now all these different systems will have will have ways to share data using the fire standard. Some of in the transition from HL7 V2 V3 to FHIR, some of the improvements that were made. V2 V3 is transactional using proprietary data formats, and I think we've learned in FHIR to use more modern programming techniques. Instead of proprietary data, we're using XML and JSON formats that are easily readable, easily understood by developers. Use of REST APIs makes the data more accessible in many ways. HL7 is very, as I said, message-based, bulk data transmissions. FHIR is using granular resources that can be shared for different use cases, which makes it highly flexible and scalable and, as I mentioned, developer-friendly. Customizations were improved, and I think through all of this, we're starting to see cheaper and faster implementations of FHIR in different ways in different spaces across healthcare. So with the maturity of the latest FHIR standards and the increasing level of FHIR adoption, as well as business drivers that continue to drive further growth and adoption, FHIR has become a new common data model for healthcare. In this approach, FHIR resources are the target format for managing and persisting your healthcare data. Data can be brought into a FHIR data model and then provided to any number of consumers in a standardized way that allows those consumers to use the data for their specific needs. So data from facilities, clinics, HIEs, laboratories, other data sources can all be imported and correlated by mapping into FHIR resources. And similarly, data can be exported from FHIR into other formats that are needed by various systems, such as in research and analytics. FHIR may not be the most accessible data format, so data can be pushed into models that more natively support research activities, such as the OMAP data model. Another approach that is a way to interface with FHIR data through SQL, which allows access to relational database tools such as Tableau, Power BI, and those interfaces can make the data accessible to those different tools, as well as developers that are skilled in relational databases and SQL. And then applications are able to access FHIR directly as well through APIs, which allows for innovative development of clinical and patient data tools. So InterSystems, as a solution provider, allows you to use FHIR as a common data model for your enterprise. Data can be ingested in any number of sources in a variety of formats. Data, as it's ingested, is cleansed, normalized, and harmonized with the FHIR data model by converting it into standard data resources, FHIR resources. This can be done in real time as messages flow through a system, or it can be done in bulk operations or even at data at rest. All data can be, for an individual, for a patient, let's say, can be transformed and aggregated as a FHIR representation. So this repository allows FHIR-based applications to use that data for patient-based care, value-based care, quality improvement, research, and any number of use cases. InterSystems cloud services are highly composable, which means that depending on the level of sophistication, FHIR adoption, technology in an enterprise can use different tools and techniques to match your specific integration challenges. So in this ecosystem, InterSystems FHIR server becomes the hub. It's a massively scalable FHIR resource repository that supports all FHIR resource types. You can implement it as a data repository or as a facade for efficient integration with legacy data. So with a facade approach, legacy data will remain in its original source format, and the InterSystems FHIR server will automatically transform and translate that data to FHIR format in real time in response to queries. FHIR server can be deployed on premises, in a public cloud, or as a cloud-based service managed by InterSystems. It's also offered as a SaaS solution for operational simplicity. The SaaS version allows you to store healthcare data in a cloud-based repository and access the data from any application through REST APIs. InterSystems Health Connect is a real-time integration system that can transform messages from source systems in a highly scalable cloud environment. So that's a very effective way of importing data from these various other healthcare formats, including proprietary formats, into the FHIR system. Our Bulk FHIR service lets you efficiently import or export large data sets for research, analytics, or other use cases. With Bulk FHIR, you can retrieve large volumes of FHIR resources in a single request for greater efficiency. And integral Bulk FHIR makes it easy to manage large amounts of data across different systems and locations. The FHIR's transformation service is a SaaS offering that offers pre-built transformation logic to automate data into FHIR format. And then in addition to the API access provided by the FHIR server itself, the FHIR SQL Builder lets you create custom SQL schemas based on data in a FHIR repository without moving to a separate SQL repository. So that way you can access SQL projections and query data in real time using those tools. So at this point, I will stop sharing and I will turn this over to Elijah.
Cool. Thanks, Dennis. So I'll just share some slides quickly, and then we'll basically get straight into a demo. I think, Dennis gave a fantastic overview about, firstly, the relevance of FHIR internationally, but I'll give some additional context in how we've seen it used in the UK, the US, certain EU countries as well. But firstly, just to sort of get into the FHIR server itself, and when I talk about the FHIR server here, we are talking about a fully sort of SaaS cloud offering. I'll sort of just quickly run through some of the main themes here. So when we're designing the FHIR server, there are 5, 6, 7 or so core themes that we're really looking at. So firstly, security and authorization. This is sort of an integral part of any interoperability at scale. So FHIR does have established implementation guides for interoperating between certain health systems. So we want to fully embrace smart on FHIR application development, for example. Health information exchanges are subject to stricter requirements. In some cases, EHRs are subject to certain requirements. So being able to sort of support these different authorization flows and then sort of validating incoming requests is sort of an integral part of any FHIR server, let alone any health system. We'll be talking about data quality as well. So this crops up in a few different places, but FHIR is actually, I'd say, quite uniquely well designed to actually handle data quality. And back to what Dennis was saying, that's because as it's sort of adopted, modern software paradigms, it's REST-based, and it has a very sort of flexible, extensible data model. Actually validating these models is something that the wider FHIR community has provided a lot of support for, and we integrate with those tools. Analytical modeling. So this is kind of where the value of the FHIR server, I think, really becomes apparent. So going beyond sort of just data exchange, we want to look at data analytics, and there are, again, a few different ways to sort of try to work with this, but persistence is quite key for this sort of thing, and we'll get into some of the techniques that we use to really try to expose the most out of these resources. Bulk access. Dennis gave sort of a great explanation initially about how we support Bulk FHIR, but we'll be looking at that in more detail as well. That's a particularly exciting area, I'd say, in recent sort of FHIR implementations. And then extensibility and scale. So this is always going to be a core part of any server offering, and it's really integral to our design. So, in offering the service, we expect there to be sort of a constantly growing number of data consumers. Particularly in the US, we're seeing sort of electronic health apps, we're seeing patient portals, we're seeing EHR integrations growing at a pretty staggering rate. A lot of that is mandated, by regulations. Certain rules about patient access to their own data, for example, is putting more sort of stringent requirements on EHR vendors in particular to expose more and more of this data to provide better integrations for solution providers. So it's a good time to be working in health interoperability. And in fact, what I'll do before I start talking about this too much is I'll give you really a quick view of the FHIR server. So as Dan has sort of stated, this is really the hub of all our FHIR operations. You can sort of think of this as a web server with, you know, quite a few specialized components underneath to really work with FHIR data. But in this case, what I've got already set up is a FHIR server, and I've loaded about 1,000 patient records, synthetic ones, of course, which totals to a little over 1 million patient resources in total. So these are sort of patient compartments. There'll be shared resources like practitioners, locations, that sort of thing. There'll be medications, observations. If you're not familiar with all of these terms, if you're somewhat new to FHIR, that's completely fine. We'll sort of talk through some examples. But just to sort of give you an idea of what an actual FHIR server, how we manage a FHIR server at a high level, we'll sort of walk through setting that up. So in this case, I've already set up this FHIR server over here. You can also see there's a version down here. This actually, this is the specific version of FHIR resources that we're looking at. So I think Dennis mentioned that, you know, the first sort of implementation of FHIR came out in 2014. The first normative implementation, which is R4, came out in 2019. With each version, there are modifications to the actual FHIR data structures themselves. So the FHIR resources get updated, profiles that are built on top of them are often updated, and there's sort of new functionality that becomes required or optional, experimental. So having versioned servers is going to be a good idea. So I'll just show you sort of, if we wanted to theoretically set up a new FHIR server, for example, I might call this, if I wanted to work with some R5 data, I might call this something like my R5 database, and then I can modify the URL down here. Maybe I'll call it FHIR R5, just something simple like that. And then let's actually change the version to something. Now, in this case, we'll sort of talk through what a package is in a bit more detail, but what I'd say is that actually, if I click back to R4 and I take a look at this dropdown, you'll see that FHIR is by design a highly extensible framework. It's a highly extensible standard. And so actually, I'll talk through some particularly interesting examples that have come up from the NHS. The NHS publishes their own extensions for quite a few use cases. You can see down here, we've got NHS England Genomics. So that's something I'd like to talk about. But the idea with this is, in addition to having a baseline sort of implementation of a certain FHIR version, we can also load in additional sort of extensions, additional search parameters, that sort of thing, depending on some more specialized use cases. So what I've actually done in the original server is I've loaded in, I think, all of these packages, but I'll sort of walk you through that as well. We do provide some more advanced capabilities as well, particularly in case you want to actually modify the sort of search operations yourself. So we call this an interaction strategy, but really what that means is you can modify some of the actual underlying logic in how the FHIR server handles incoming requests. So we actually see this in the US quite a lot with some payer implementations. They're subject to sort of a pretty intensive set of regulations coming into effect in 2017. That probably doesn't get talked about much in the UK, at least, but as part of this, there's a huge number of implementation guides that need to be considered with a lot of depth to them, mostly focused around exchanging large amounts of data between health providers and health insurers, or payers, whatever you want to call them. So we do see, certainly some quite advanced use cases where it becomes very necessary to modify these strategies directly. So I can click create there, but actually for this demo, I'm going to be using the core server over here. So the other thing I'll quickly take a look at as well, within this database that I've already loaded, we can sort of take a look at the shape of the data. So as I said, this was synthetically generated. We use Synthia to generate a little over 1,000 patient 2,000 patient compartments here. So what that really means is we have a large number of observations. So these can be anything from blood tests, they can be BMI measurements, for example. A single patient is likely to have quite a few observations, even from a single check-in at a clinic or a hospital. Similarly, we have procedures, medication requests, encounters, conditions. You can sort of get a sense of what each of these resources do. But if you're unsure, then HL7 has a very, very detailed spec. And then let's have a list resource that I created over here. So we can talk more about these as well, but these aren't just sort of clinical resources. There are all sorts of structural resources that you can make use of, particularly when you want to run sort of certain search logic over the FHIR server itself. So there's if you take a look at the FHIR spec, you'll see that actually resource types are often categorized. Sort of clinical, administrative, structural, security, that sort of thing. So as a standard, it's very detailed and provides sort of a lot of support for different use cases. But that's going to give you an idea really of the FHIR server itself. Just how do we get set up? Where do we start really? This is the hub. Next thing I'd like to talk about quickly is I sort of alluded to this concept of package management. So for those of you that are very familiar with FHIR, this will probably not be much of a surprise. But for those of you that aren't, I'd recommend taking a look at simplifier.net. You can sort of think of this as the FHIR package management backbone. So for those of you that work with Python a lot, think of this as PyPy, or think of this as UKI or something. So in this case, I've actually taken a look at the NHS England organization. In fact, if I go back to their page, if I go back to the homepage of simplifier.net, you even get an overview of how many package implementations there are per country. So the US is leading with this, over 1,300, but the UK also has nearly 400 implementations, a lot of which come directly from the NHS. So countries will often have, I guess, core implementations. And as you'd imagine in the UK, that core implementation comes very strongly from the NHS itself. So in fact, if we even click on the UK here, we can take a look at NHS England. That's one of the main contributors. And then we can see some of the packages that they've actually published here. So one thing I was interested in was this, NHS England Genomics R4. So this is an implementation guide for basically a genomic service. So this might be a way to upload genomic test results, make orders, get status updates on any genomics tests that have been published. I mean, really what this is designed for is specialists or clinicians who need to request genomic data, for example, could make use of these FHIR extensions implemented within a larger health system. So that's kind of the idea with these packages. They want to provide, I guess, better resource capabilities, better search parameters, extensions to FHIR resources to really allow for these use cases. You might also have genomic test labs, doing sequencing or analyses that maybe need to be shared with other health providers. Researchers, of course, might want to leverage standardized genomics APIs for population level analysis or large case studies. So in fact, if I click on this, you can see this is, we don't necessarily need to look in much detail at what's actually running behind this, but we can see dependencies for this package. So the idea is each of these will need to be part of your FHIR server before you're able to implement this. But if we're interested in playing around with this, we can actually install this directly with npm. I do that. Then this should basically download the entire package for me to use. That works. Yeah. And now if I go back to my FHIR server and I go to my server running over here, what I can do is I can actually select the downloaded package over here. So I'll go to my directory, packages, node modules, and it would have been this. So if I click upload, see is that there were sort of 330 files in here. So a lot of these will be structural definitions. They might be search parameters, for example, that build on top of existing dependencies. And in fact, we can even pass all the dependencies here. So we will validate that the packages themselves already exist on the FHIR server so that we can correctly build the search indices and that sort of thing. So if you're happy with that, we can read the version as well. Click import. Then see, the package is currently be used by one or more endpoints, therefore it cannot be uninstalled. Okay, that makes sense. So what I've done is I've already had this uploaded. So it's already being used by other packages. So we can't actually replace the installation here. But what you'll see is that it is actually here underneath the R4 core implementation. So that's sort of a super fast tour of how you can deal with custom packages. This is becoming more and more relevant. It's very sort of, it's part of what makes FHIR so valuable, the ability to sort of define these extensions on top of the core standards as well. So for really, any kind of advanced use case, particularly with government regulations as well, they will typically rely on these implementation guides and these packages to really try to enforce the quality of data that's moving through. So what I'm going to do is I'm actually going to jump back to the presentation quickly, and I want to talk about a couple other things. So I sort of, we've been talking about this concept of bulk FHIR as well. So for those of you that aren't familiar, I think this is maybe one of the most exciting advancements in FHIR in recent years. So it's conceptually, it's quite simple. Health networks, providers, insurers, that sort of thing, they often need to provide large exports of FHIR asynchronously, either within an organization or as part of some kind of trusted network or partnership. If you think of clinical research, population health, surveillance, disease monitoring, that sort of thing, being able to exchange large incremental batches of data without necessarily knowing the exact queries you're going to run afterwards. The goal is sort of to open up FHIR to work with population level data sets. And that's really what this slide is trying to illustrate. Bulk access has been published as an implementation since 2019. And particularly in the US, there's been a massive push to sort of implement bulk access APIs as part of data exchange regulations, particularly between providers and payers or insurers. So, there's regulation in place that affects every Medicare partner organization and a very large number of health plan insurers. And part of that is reliance on this sort of bulk exchange capabilities. And in fact, in the US, it's actually become a mandatory part of EHR certification, I think in 2022 or 2023, to actually support some level of bulk access. So every EHR operating in the US to get certified, that's Epic, Cerner, Meditech, they need to adopt some level of bulk access support. And a lot of this is really to just try to drive innovation outside the EHR, as well as being able to support stuff within provider organizations. And we're also seeing sort of specialized movements towards patient access initiatives that make use of bulk access, specialized solution vendors working downstream of EHRs, companies that are building analytics solutions, patient engagement platforms, personal health platforms. They're quite serious about this level of data movement. And just in terms of a quick technical overview of how this actually works, this diagram is detailed. But really, this is it's an asynchronous kickoff. So I can ask my FHIR platform, for example, hey, I need an export of this group of patients, and that might affect every related resource within the patient compartments. There's not necessarily a limit on how many patients can be affected with this. That's really up to the FHIR implementer to decide. But once I kick off this request, it's fully asynchronous. So the server might take 10 minutes, it might take 2 hours, it might take 8 hours to actually produce the results for that. It depends a lot on what you've requested. But part of the spec allows you to sort of repeatedly poll the server for the status as well. So you can try to work out, is it ready? Is it not? Is there an estimation of how long it's going to take? I don't think there have been many implementations of that kind of prediction. It's mostly a yes/no type of thing. But once it is ready, this is entirely file-based. So FHIR platform will produce these exports. It's basically very large sets of JSON. And And this is also compatible with smart backend services. So this sort of goes back to the authorization stuff that I talked about. You don't necessarily need to understand this in a ton of detail, but Smart on FHIR is an initiative to really sort of improve secure access to FHIR resource servers from applications, particularly if you're interfacing with an EHR or if you're being launched from an EHR. In this case, we treat this as a sort of backend service. So, a clinician wouldn't necessarily kick off a bulk export like this. They wouldn't need to have their particular permissions attached to kick off this type of thing. So really, we consider this a backend service, which is typically going to be two sort of data management systems talking to each other, not so much about a clinician being able to view certain records or a patient being able to view certain records. And these different implementations, bulk access, smart, they are often sort of built on top of each other. There are interdependencies. So communication within the FHIR community is key. Just be careful about what you're building on. In terms of how we've then dealt with this, is we sort of saw this interesting opportunity. We are, a sort of a data management company at our core. So with the launch of Bulk FHIR, we sort of built out some really what I'd describe as an exchange engine. So the concept is quite simple. These bulk endpoints or even endpoints that don't natively provide bulk data on the left-hand side, they could be healthcare providers, they could be clinical offices, they could be research labs, they could just be huge research data sets online or in other databases. Being able to sort of pull these data sources, out of the box without a ton of engineering work around that, being able to schedule these and run data quality checks on the resources coming in, especially for very large batches, is incredibly important. And not only that, we want to bring that directly into a FHIR server where we can make use of it. Simply having a FHIR resources in a file format is of very limited use. So again, making use of a FHIR server that can actually support the search operations and can actually efficiently index against all of these records. It can run quality checks to make sure that every observation links to a real patient in the repository, that sort of thing. It's incredibly important to actually get value out of this data. And once these checks have been run, you can also push it externally. So we have implementations where any resources that fail quality checks, we actually push them to a file system. So you can download them and you can take a look. You can try to work out what went wrong. We have, we're exploring implementations to actually get this hooked up to certain AI platforms. So typically this might be a subset of some of the data coming in, but once it's gone through the FHIR server and it's been validated, it's actually very easy to retrieve sort of finer grained subsets that are a bit more useful. So what I'll do is I'll actually quickly jump back to the FHIR server to really show you how we implement this. So again, this is all the same deployment. What I'll do is take a look at what we call the Bulk FHIR coordinator. So these are some of the configurations I have built in. Take a look at this first one, for example. I call this ingest incremental patient updates. And this is sort of a four-step process. So what we do is firstly, we, as part of the FHIR standard, every interaction with the server is over REST. So what we do is we actually provide a REST endpoint to kick off our own coordinator. So and that's what this is, this client authentication. This allows people to kick off these requests over an API that we provide. But the coordinator configuration itself, if I take a look at this, for example, excuse me. So we can control certain things like where should these API calls come to on the FHIR server, you have sort of full control over that. Which users are actually authorized to kick off these requests? We do actually have a built-in OAuth server for anyone that wants to use that and doesn't necessarily use an external IDP. So in some cases, you may actually want to hook this up to that as well to validate certain scopes and be able to validate which permissions specifically do users have before kicking off these requests or anything else. And then I'll take a look at the actual server adapter over here. So this is how we talk to the upstream system. So in this case, I have a custom FHIR endpoint adapter. So this means that I'm connecting to a system that may or may not natively support Bulk FHIR, but we can still construct the bulk export. The authorization type for this system may vary. So maybe basic auth, OAuth, maybe they use API keys, for example. For smart backend services, this will typically be OAuth. Well, it will always be OAuth, but just for the purpose of a demo, I set up basic. And then we have sort of credential management built in as well, so we can securely store user passwords, API keys, that sort of thing. And then the endpoint itself over here, I'm actually connecting to a different FHIR server in the cloud. I'm connecting to its external IP address, and then this is the endpoint that we're loading from. And we can also choose which resource types we want. So maybe I only want to pull in patient resources, or maybe I want to pull in everything. Maybe I want questionnaires, medication requests, And as you might imagine, depending on the FHIR implementation on the other end, if something supports a system export, which would literally pull everything in a FHIR server and bring it out, you may want to filter this down based on resource type, or you may want to filter it down based on, when were the resources last updated. I only want to load incremental batches, for example. Having these sort of parameters to really control these exports is extremely important. And then finally, what do we do with the data once we've retrieved it? So we have a few built-in configurations here. In this case, I actually want to load it directly into a FHIR repository. So if I take a look, we can also serve failed files. So that's anything that didn't pass an integrity check, for example, or anything that just couldn't be persisted for some reason. Maybe it had a conditional check within a resource bundle that, and the condition failed. We need to be able to get these files out, get these resources somewhere else to be analyzed. And then we actually choose the FHIR endpoint. So you can see I've got a few different endpoints here available already, so I can just choose whichever FHIR server I want to load this into, and then save. So that's really just how we set up this exchange engine that I sort of showed back in this diagram. We want to set up the what we call the fetch adapter. So that's where we're pulling this data from. We want to set up authorization at every step. So it's not necessarily illustrated here, but when you think about the users that actually get to kick this off, at every stage, we need to validate that they're able to do that. And then where do we want to send it? How do we want to quality check it? That sort of thing. And in fact, I've got some examples here of exports that have run. So in fact, here is an export that errored out. But over here, I can see there were 2 completed exports over here, ingesting incremental patient updates. Over here, for example, I have this EHR group loader. And if I take a look at why it failed, I'll view the logs, unauthorized request. So what I tried to do over here on a slightly separate configuration when I kicked off the request, actually the FHIR endpoint that we were querying on the other end said that we were unauthorized to query for this particular group of patients. So even when these exports fail, we still have a very clear log of what exactly happened. And then if I go back to the ones that succeeded, we get some slightly better news. In fact, we can have an entire log of every single activity that took place here. So we like to make use of native bulk endpoints, but some FHIR servers don't support these. So in fact, what we did here is we composed a bulk export from repeated querying of patient compartments. That's what you're seeing here. All of these REST requests and the fetch adapter, we can actually drill down to each of these, see what was going on. So we were actually polling for every sort of patient ID within that group or within that particular FHIR server, depending on the type of export. We could actually retrieve all of that information and construct a valid export from that. So that's really what we did built in here. And again, a patient identifier here, we're not actually exposing any of the information about the patient itself. That's stored securely within the FHIR server. And yeah, that's sort of what I want to cover in terms of bulk exchange here. You can see there's a lot of potential here in terms of, I think, really in terms of clinical research, population health analytics. And there's been a big push in the FHIR community with, for those of you that are familiar with FHIR accelerators, you may have heard of Helios, for example. They've done some really interesting work trying to hook up to sort of immunization systems, particularly in the US at the state level, and trying to build meaningful population health analytics directly on top of those databases with FHIR. So, we expect to see more and more growth in bulk usage, and we want to be able to support all of the innovation that comes downstream of that. And then I'm running a little bit low on time, so what I'll do is I'll quickly go through just one other thing that I really want to mention here. So without getting into too much detail here, there are FHIR is just built on implementation after implementation. At some point, people realized that having sort of a navigation language within FHIR resources would be useful. So that's what FHIRPath is. It's an expression language that allows you to sort of precisely navigate through each FHIR resource through the actual structural definitions that we have on the server. So this is an example over here where we're looking at a patient resource. And we can see, well, within the name element of the patient resource, there are several sub-elements. What's the family name? What's the given name? What's the usage? There may be other things like what's the status of the name? If the name changes, there may be dates attached to when that name was changed. And so within that, you get this sort of interesting ability to apply filters or joins, or if I want to just select a few elements from a resource, maybe I want to look at patients with a particular family name, and I want to join that with observations of heart disease. That might be a use case. Maybe I want to look at population health across a network, and I want to filter by certain indicators or observations, and then join that with certain demographic data. The point here is that FHIRPath sort of gives us a language to actually flatten this data. And that's sort of what we did with something that we call FHIR SQL or FHIR SQL. So we made use of this expression language to actually flatten the data resources that we wanted and actually build a fully relational projection on top of the server. So I'll sort of show you that very quickly. So what that looks like over here, again, from the exact same deployment. I log into the SQL builder. What I did here is I actually ran an analysis of the FHIR repository itself. So this is the one with about 1.3 million resources in it. I told it to analyze about 10% of those resources. That's why you see 134,000 here. What this does is it actually basically runs through and builds basically histograms of all of the resource contents within the server. So there may be certain profiles that are made use of. There may be certain extensions that you hadn't thought about. We can basically analyze how many of these are populated. And then what that allows you to do in this sort of transformation spec is you can then actually scan through the contents of the server here. You can see 800,000 observations. That matches what we saw in the resource dashboard earlier. And I can say, well, I'm interested in observations. I want to know, firstly, who was observed, who was the patient or the subject that was involved in this observation. So I can add that to my projection. I think it's already in there, but I just add it again. I might be interested in the actual code itself. So what was observed? Was it a blood test? Was it a BMI? Was it, whichever measurement itself that was taken at this point, we can add that. And we can do this across different resources. Maybe I want the patient itself. So once I've added the subject from the observation, I'm going to want to link that to certain patient data. I'm going to want to link it to certain encounter data. So once you've sort of built this transformation, you can then just define the projection. So this is quite simple. What I do is I say, for this multi-resource operational measure that I defined, I just want to turn this into a SQL package. And what that means is if I go to dbeaver, for example, I can run a quick query and I can say, so what I've done is I've actually connected behind the scenes to this FHIR server, and I can say, I want to select star from projection.observation. And in fact, what this shows us is these are all of the fields that we selected specifically. So firstly, we've got the key for the observation, what's the observation code, but maybe, a bit more user-friendly is what is the actual display. So we can see we have measurements here for body height, BMI, respiratory rates, are they a smoker, that sort of thing. And we can actually see the codes themselves. And importantly, we can see references to other resources. So that's what this column is here. Think of this as a key to something else. In particular, think of it as a key to maybe patient resources. So if I quickly run this query, we can also see stuff like, how many sort of patients were there in each gender category, for example. So we had a roughly even split between male and female patients from the 2,000 or so patient data set. But you can see quite quickly how easy it becomes to actually start running, I guess, native sort of relational analytics on top of this thing. And in fact, if we go one step further, what I did is I actually built a Power BI dashboard over here, which hooks up to the exact same thing. So in this case, there are a few different widgets here, but over here, what I'm looking at is observation values and patient genders. That's actually joining across two separate resources. It's joining over observations and it's joining over patients. And this is working natively from the FHIR server's relational projection itself, right? All we did was hook this up to the FHIR server deployment after building that transformation. Over here, I've got counts of observations at each location. So, I can see that the Framingham outpatient clinic, for example, has maybe a unusually high number of encounters over here. And then I can sort of drill down to any of these. So if I take a look at this particular patient, what's their birth date, 1977, I can take a look at like an A1C measurement. And over here, I can see, where was the encounter location that they were seen at. The point is this hooks in very well with sort of native, Power BI tooling that people use. And to give you sort of a real example of how this has been used in practice, I go back to my slides quickly. It's a slightly low resolution screenshot, but there is a link down there. This has been used in implementing COVID reporting, for example. So the Israeli CDC, what they did is they wanted to track COVID cases. And in fact, they had sort of a live reporting tool. I don't have a video here, but if you take a look at this link, we'll send out slides afterwards. Maybe you can't view it properly with my toolbar down there. But yeah, this really is about, how do we run operational analytics directly on top of a FHIR server? So not just interfacing with it over REST, but also being able to make use of larger scale queries, operational queries that are actually typically not going to be very well supported by HTTP. So that was really everything I wanted to cover. There are sort of bits and pieces here that I haven't looked at in much detail. I didn't actually show any example queries to the FHIR server. We could definitely look at that as well. But if you wanted to look at active medication prescriptions for a patient, chaining search parameters like this is extremely easy with FHIR. If you use a nice tool like Postman as well, they'll lay out the query parameters for you. But in this case, this was a patient ID that I was interested in. And I can see all of the medication results that we have for them in the FHIR server. So in this case, I'm not a clinician. I'm not going to necessarily know the significance of all of these, but what I can tell you is within each of these sort of identifiers, we're actually pointing to another resource in the server, a medication resource. And again, this is kind of the value of FHIR. You have this sort of reference-based graph structure. So if I'm interested in the patient's medications, I'm going to get references to each of those resources, and you can sort of drill down and compose these however you need. We can also see, for example, usage of additional profiles. So we talked about this a little bit. There's no sort of genomic-specific medication here, obviously, but we would expect to see, for example, certain observations that maybe extend the NHS genomics package, for example, depending on what the nature of the request was, what the test results were, that sort of thing. So yeah, there's a tremendous amount of depth here in terms of what you can do both over REST and both over SQL. And equally, if you are interested in any more information, reach out to myself, reach out to Dennis. We both work on this a lot. We deal with a lot of sort of use cases, both in the UK, but also just internationally, really. And in particular, it's very interesting to sort of see the adoption levels vary between countries. Regulation is the biggest driver behind FHIR implementations. We haven't quite reached a point where the value of the implementations themselves are enough to warrant further implementation, but I do think we'll get there, particularly with smart on FHIR development. The more value we can get from existing data sources, the more valuable those assets become. So yeah, it's an exciting time to be working in FHIR, definitely. And get in touch with any questions. I would love to hear from you. Oh, and I'm not sure, Loretta, did you want to maybe cover this in terms of sort of upcoming events for the UK?
Yep. So we've got our UK Data Summit coming up next week. That's in Birmingham. So there's still time to register for that, and for our Global Summit as well, which is in June, and further tech talks as well.